Long time ago, I created this repository to share the steps to cross-compile Qt for Raspberry Pi. Now we are going to add extra steps to cross-compile OpenCV for Raspberry Pi. If you haven't watched the previous tutorials to understand the theory for the Docker isolation, please watch the previous tutorials, otherwise you will not understand the content here. All the commands steps are in the repository already, but I'm going to show you what I did to cross-compile OpenCV. It is quite simple. All dependencies are handled already in the repository. You need to just run a couple of commands. If you have Docker and QEMU, you don't need to do anything. You can cross-compile OpenCV on any platform. So before start, I'm going to recommend you to again and again watch the previous tutorials, okay? Otherwise, you will not understand what is going on here. I'm not going to explain you what I did before in the previous tutorials. So let's start with cloning Qt on Raspberry Pi repository that you can find the steps also here for the Qt compilation, cross compilation. As I told you before, all the steps are available already. So what I'm going to do now, what I'm going to show you now is only what I did before. So you can follow this pattern later if you need something else also, like instead of OpenCV, if you have other libraries, third-party libraries that you want to compile crossly, you can follow this pattern, these steps. It will be quite same, okay? So we are going to add OpenCV now together. So I just clone the repository now, enter there. When you check the content, there are some, like files, directories. These directories are these ones are old ones that maybe I should delete them or move somewhere else. But mainly we have Dockerfile, Dockerfile app, Dockerfile reps. This Dockerfile resp is for the ARM environment that we create the Sysroot from this. That is the only reason we have. And to run this Dockerfile rasp, we need QEMU. So for installation, you can check this README, or also you can watch the previous tutorials. You need QEMU and Docker for it. Then Dockerfile is the x86 hardware itself. So we will make the cross compilation inside this file. So just now 2 Docker files. This is for example compilation. Like if you have a project, you can use this file for compilation later, for cross compilation for your project. Now we can also add like another project, another example for the OpenCV with the Qt that we are going to do that together also. Let me open the VS Code here. Okay, so we have Dockerfile rasp. As you see here, this is the first stage. I called it as a stage. Maybe I can just delete this. I don't know. But we have a bookworm now here, right? This is the same operating system, same version with the Raspberry Pi now. And this is ARM64. So if you use 32-bit Raspberry Pi operating system, this will not work for you. You have to update here. I haven't tested yet with the 32-bit, but I saw that some people tested already. So it is working still. I have 64-bit operating system. That's why I use this. So be careful. What we are going to do, there are already the files, like there are already the source list is up to date. And what we are going to do now, we need to add extra dependencies here for OpenCV. OpenCV itself. I'm going to just copy paste them and talk about it. You can ask yourself which file I need, the dependency do I need to run to compile the OpenCV. This is a good question. You can search on the internet, or you can make mistakes and learn it from it. That is what I did. I tried a couple of times and I get the configuration as a result, and I saw some problems and I solved later. But for you now, I'm going to just show you copy paste what I did for the development packages and other dependencies. Simply we need like some mathematical libraries and mainly GStreamer libraries. So these are, for example, there are more than necessary actually. Some of them are not necessarily here, but I add them anyhow. That does not hurt me now. So there are OpenGL. So the idea is, right, we use these dependencies to build the Qt, and some dependencies are common with the Qt and OpenCV. So we are going to create a Sysroot file. This is the beauty. We are going to create a Sysroot file, and this Sysroot file will be used later for OpenCV and Qt together. This is good. So mainly for the Raspberry Pi, for the OpenCV, GStreamer is enabled. You need these things. And GTK. I added the GTK, but I wasn't able to enable it. I don't know why, for the OpenGL. I added also the OpenGL libraries that was already there also, like a Mesa, Common Dev, like this one too. So these were already needed by Qt. So these are okay, this can stay. Couldn't enable the OpenGL for OpenCV. I don't know still reason, but I don't need to enable also because this is the configuration result, configuration summary for the OpenCV that you can find in the web site, also in the repository, or inside the image that you can create this yourself. So OpenGL support is known now for me, and this is for GUI. But we are not going to use OpenCV for GUI, right? We are going to use Qt for the GUI. For most of the case, I think this is not needed now, but I don't know why I couldn't enable this. I still don't know the reason. Then I skipped it because I don't need the OpenGL for now, for the OpenCV. OpenGL is enabled for Qt. So we can use together with the Qt and OpenCV, and Qt can access the OpenGL, so it is okay for me. But for the other important configurations, like for the video configuration, looks good. GStreamer here with the version is yes. Some codecs are yes, enabled. Some codecs are enabled. Looks good. These are fine. So this is what I want also from OpenCV. That is it. I have the only this is the only problem now, but I don't know, maybe there is a problem with the OpenCV, the specific version that I created here, that I compiled here. Maybe, I don't know. So maybe I can update this later, but it's not really needed if you use a Qt. But if you don't use Qt, so then you don't have OpenGL support for the OpenCV. You can still use like normal X server or like without OpenGL, but this will take there can be performance problems maybe. So we added the dependencies, dev files, or like the GStreamer dependencies, libraries, and be careful that you need these dev files. There are some dev files or development packages. These development packages brings you also some for the compilation for the OpenCV. This is necessary, and it brings you some shared object files to point later to the correct version. If you miss this, then compilation will fail. And also we should add here that I forget before, the etc alternative directory. You can ask, what is this now? What does it mean here? So let me show you. There is an Raspberry Pi here that I connected from a VNC that we are going to use this also OpenCV, the Raspberry Pi to test to OpenCV later, that you will see. So if you check, I cannot type. Good. Why I cannot type, man? Come on. If you check etc alternatives, you will see bunch of some files, gz files, and you will see somewhere, if I am not wrong, some kind of symbolic links here, especially these ones. These are symbolic links, so you can ask why the heck these symbolic links are here. If you ls one of them, this VNC is so slow, minus maybe. So this points to somewhere with some specific version of this library in the usr-lib directory. So Linux needs to know which version is available for this library. So this is kind of a version controlling system. So if you forget the etc alternatives in the Sysroot, symbolic links will be broken, and it will take time for you to understand what is the problem. Compilation will fail because it cannot find the correct version. So if you check this here, like for example, like this one, we can check this one. There is with the -l, of course. So this points, there is also like a libbus. So this is a math file. OpenCV needs this library for the compilation, also for the runtime during the runtime. No, this is not correct one, blast. So that we should check in the one in this directory. So here. So this one points to etc alternatives lib plus whatever here. So if you forget the etc alternatives directory, the linking will be broken. So be careful. We need also this in the Sysroot. Okay, I just saved the file. Looks good. We have some dependencies here for the OpenCV and for the Qt. Some of them are all together, and now there are also some of them are not necessary probably, but I added them, but let's keep them. Sometimes you need, today maybe you don't need this dependency, but later you can have need. So later you can need, so let's keep them now. Our intention is to compile OpenCV, right? Cross-compiled OpenCV. I'm going to add here the flag first, because maybe some people do not need OpenCV itself. They can need only Qt, right? So Qt is default. Qt will be compiled anyhow. But I want to create a flag to control OpenCV build. If you make it on, if you make it true, OpenCV will be built with Qt. If you make it false, then the OpenCV will not be built. I'm going to give the name. I'm not good at giving name stuff. So build. By the way, I'm not going to run this comments really I did before, right? I'm just going to show you here. So there can be typo of something, so don't worry. You can find the old comments, everything in the website, in the link, but just follow the steps, to understand the steps here, because people asking questions me and they don't understand what I did. So they're asking weird questions. So understand first. That's why I'm trying to show you. So OpenCV, I don't see keyword. Like this is off, I don't know. Then we need to add another run block, like before here, for example. So we need to fix the symbolic link anyhow. So we can move this symbolic link outside somewhere. So like this. So that then we can delete this here. We don't need this symbolic link fixing in the Qt compilation anymore. Now we have Sysroot, then later, but I think, yeah, this is okay. Another run command here to build OpenCV. So let's then give some command like build OpenCV. Run if build OpenCV is on. But I think this should be also, there should be here. And I think these parentheses are not needed. Yes. Then while creating this image, if you make this flag on, OpenCV will be built together. Nice. Then, and I need to print everything into the build log for debugging purpose. You know, like if there's an error, it will fail. It's not just like a Linux command. Then, like we can give some kind of echo. We will create another directory in the -p, like we did here for the Qt, to not to mix up everything in the image. Build OpenCV, yes, called OpenCV. Then we need to clone repositories that I'm going to copy it here faster. So be careful that I copy like I just a clone 4.9 version. So there are different versions. I tried the master, the latest commit, but it didn't work. There could be buggy situations, so I recommend you to use specific version. That I use this version now. You need also contrib the repository for the additional tools, the modules. Okay, let's use this directory to keep the build files. Then we can create another directory. If you see that I use every time this like end here, because it is like a chain comments. So Docker, you know, will understand this is a chain of comments and it will run each comment one by one later. So we need a CMake commands configuration now. It's going to paste. So just as a usual CMake like a configuration, there are some flags that you need to set. The main ones here, like the install prefix, like the end OpenCV build will be in this OpenCV build directory. So you need to show the path for the extra modules in the contrib that we just simply, you know, like clone here. We are going to write the toolchain also for the OpenCV. You need a toolchain. If you have a cross compilation, you need toolchain. So we are going to write it now. And there are some flags, important ones. GStreamer is on, FFmpeg is on, like OpenGL is on but doesn't work. I don't know the reason. Maybe I can solve it later. Maybe it's not really necessary. So I just turn on the X11. I disabled this Qt and the GTKit. Be careful that Qt is the old one here, Qt 5. So I was thinking to disable it because I don't need it. And like I don't need a Python. I also enabled this, but this is not really necessary. You can delete it. Let's delete it because it will be on anyhow. And I disabled some tests and examples. There is it. Looks good. Then we need CMake build. We need to build this right now with a parallel execution. A 4, if you have a 4 CPU 4 core, it will be in the image anyhow. It's okay. And CMake install here. But be careful, the installation will be in here, right? In OpenCV build. That's why we created in the beginning this directory. And that is it actually. Now then we simply tar this directory -c, as I understand, zvfs OpenCV. You need to give the name for the tar file. I'm going to say OpenCV binaries tar gz -c build OpenCV. So this is ready now that we can, but it's not ready that we need to create a toolchain, right? But the configuration is like this, quite simple. So let's create a toolchain now. Let us copy paste also from previous toolchain that I use for the Qt. They're quite same, but I like to create a new one. This is the toolchain file that I coded before. So I just simply, you know, like a global guard and the version that I choose. These are not really important for now. But the important things here, like you need to choose the correct processor, architecture, 64-bit, and Linux. And you need to give the Sysroot correctly, build Sysroot. That also same with the Qt. So if you check, let me show you where did I create a Sysroot. here. So work directory is build. So when you say make their sysroot, it will create a sysroot directory under build. So this should be correct, otherwise you will have an issue. And you need to give the architectures again. You need to just create a, you know, like the flags to use later. So also important thing here is like the version that for the compiler. Compiler version is a 12. If you check in the Raspberry Pi itself, this is also 12. And it is so easy to install it with this kind of approach, because here you don't need to create, you don't need to compile the cross toolchain, the toolchain itself. So it is easy. Normally, if you use like an Ubuntu, for example, now we are going to use here like a Debian bookworm, right? Also for the Dockerfile itself, for the x86. If you use a Debian, that you cannot find this GCC 12 toolchain, because they have different version for the cross-compiled one, pre-compiled one, let's say. This is the point. So if you match this bookworm, the version of the operating system with the x86, then you can simply install correct toolchain. It is so easy, easy peasy. And you can use this toolchain for Qt compilation, cross compilation, and for OpenCV or whatever you want. As long as, just be careful here, choose the correct operating system. Okay, let's continue. Where was I forgot. Oh yeah, I showed you the sysroot directory, then maybe we're in the toolchain file. I'm getting older. So like a 12 version, this is okay. You just set the compiler flags correctly. It's perfectly fine. These are the compiler optimization flags that I just figured out. There are different flags for the Raspberry Pi, for the ARM. I choose these because these are more generic. So if you want really optimization, you can choose according to your Raspberry Pi version. So it can be different for like a Raspberry Pi 4, Raspberry Pi 3. But this, when you make this like this one, it is generic. It will work for all ARM as much as possible, like a different Raspberry Pi 0, Raspberry Pi until 4, 5, whatever there. So then like there are other like OpenGL and Matlab paths here that I gave, but I think we don't need this. Yeah, it is okay to, it is, I don't think this is really needed. I can remove it and try, because we have Sysroot anyhow. But this is a good idea to give the path for OpenGL and the Mat. But be careful that we don't have OpenGL is not enabled now. Still, this configuration is exists in the toolchain and the CMake. This is for the linking. When during the linking, you need to tell to CMake, you know, which libraries do I need to link. There is one thing that you have to be careful about. The order matters here, that I figure out later. So this one should come before this one. So otherwise you will have issues. This one is important. That means this is cross compilation, right? So the settings make simply when you cross compile OpenCV, it will look the libraries in the sysroot. So this is what we need. So it will not look for the host environment. So this is the point, right? Because this is cross compilation. It should check only sysroot. Okay, I'm going to save this now. So we have new CMake file. We update already Dockerfile, right? Here for the OpenCV, we have a flag and the configuration looks okay. We already update the Raspberry Pi site, Raspberry Pi Dockerfile rasp for the packages, and we didn't forget etc alternatives directory in the sysroot. Cool. So let's create another one example quickly. At the end, we have one example for the Raspberry Pi for the Qt. Let's make another one, Qt and OpenCV together, so we can understand the compilation is successful. So I'm going to set an OpenCV Qt OpenCV example directory inside the image, inside here in the repository. So then I'm going to copy this inside the image, and if it is on again the flag, this example will be compiled. And also you see that we need again toolchain, but this will be simple quite again, like it is okay. So I'm going to create here, make the Qt OpenCV example. Okay, cd Qt. I need to create the files inside this directory. It is a very simple application. It will create a circle using OpenCV, and this circle will be represented in the window which is created by the Qt. Simple. So we just, you know, like we are going to include the headers, OpenCV headers, as you see here, and some Qt headers like QLabel, QImage, QPMX, PixMap for the conversion, and just create a matrix with zeros, you know, and create a circle. This is the way, just to draw a red circle, that I created a red circle. And this will be converted image here, convert to the QImage, Qt type now. This function does the job. This is just, you know, like create a Q image from this math object. So as you see that we are using now here OpenCV and Qt together, and it later then creates just a label type, and it will show the Q image, which is circle. Very simple. We need again toolchain, CMake file, but it will be quite simple, and just copy paste again, that you can find everything on the, in the link. Just I'm going to, you know, like I tell you. So we are going to set again the compiler and the same, you know, like the version, the architecture and optimizations that you can set. The same settings for the you know, searching path. That is it. Let's save them. Everything looks okay now. Let's run everything and let's see what will go wrong. But I'm not going to. So my idea is to show you now what you should do. I assume you just watched the video, you know, like just you clone the repository, and now you want to start the compilation. That is it. So these are the commands, only commands you should run. That is it, couple of commands, nothing more. That's why I told you to watch the video carefully. So we need to create first the Raspberry Pi, the image. So you be careful, you are using the buildx command, docker buildx, build platform that we need to choose, platform, Linux, ARM64. There could be typos here, but no problem. You can find these commands in the link below the video in the repository. Load -f the file, the path that you have to give for the Raspberry Pi Dockerfile. The name is like Docker that we just change in the, you know, like a first time in the beginning. Dockerfile rasp -t rasp, the name of the image, rasp image here. Then later, let's do it everything together in a chain, and we can create a temporary container to copy the sysroot. Create name temp arm rasp image. What we are doing here, we just copy, we created an image, right? This one, we create image, and from this image we are creating container, temporary container to copy sysroot, because at the end we are going to have this rasp tar gz, this tar file. We need this for the sysroot. Then we are going to copy this tar file, temp arm, the name of this temporary container. This, what was it? The rasp tar gz is under the build directory, rasp tar gz, and just copy here rasp tar gz. Then later, this is the time that you should enable the OpenCV Docker build. The Qt will be compiled in default, builds -t, but before the -t, you should give the build OpenCV on. Now OpenCV will be built. -t Qt cross, let's give some name, Qt cross build. I'm not good at giving names, so you can choose your name for your container. This will create image that has cross-compiled binaries for Qt and Raspberry Pi. And later, Docker creates name. Again, the temporary container, another one. Temp build, Qt cross build. Then we need to copy. There is an example also. We can copy the example. Temp, I forget. Yeah, in the example, we created toolchains, but we forget the CMake list. Okay, let's do it later. Temp build. Now example will not work because it is not complete. Build Qt OpenCV example, Qt OpenCV example. This is the name of the binary that I gave you. Qt, I just copy here with the name, same name. Copy OpenCV. No, let's give the Qt. It should be Qt OpenCV hello. You can you should decide this name in the CMake list file. Did I forget to create it now? I'm going to create this just after this command. Qt OpenCV hello. So let's stop here now and create a CMake lists code CMake lists txt file, but this should be under Qt OpenCV hello. So CMake list txt, CMake lists txt is correct. So just in the CMake lists, you need to give like a prefix path where the libraries exist in the sysroot, and I just gave the name of the binary. You should give like a, where is the OpenCV that we built, and the Qt6 directory for the CMake, for the configurations that it can find automatically the CMake files, because we need GUI widgets and OpenGL for the Qt. It will find it automatically. Then these are I think these are not really needed, but I added again. So like these are needed for the linking These are mathematical libraries the OpenCV needs. And at the end, it targets the link, this normal proper CMake list example. Then it will there should be main CPP somewhere here. Then it will create the executable and link the libraries together. That is it. Let's close this and let's continue. Then you can check this from this point, but at the end, let's assume you have this binary. You can check the binaries you can check with the file command. It's compiled for ARM or not to see, And then you can copy from the temp build here container the OpenCV binaries that you will send these binaries to Raspberry Pi. It is under build OpenCV binaries tar gz. Here OpenCV binaries tar gz. Okay, looks good. If you run this will take some time. I tried, it took 3 hours for me, and I have a 16 GB RAM on the computer. So, but I'm going to show you now, it can stay here like this. So I did already in another computer that I'm going to show you now there. So here we have OpenCV binaries at the end. When you run this command, that I just showed you, when this will finish, at the end you will have OpenCV binaries, Qt OpenCV hello binary, and the other Qt tar files that I just delete them, I think, here. So if you check Qt OpenCV hello example, this is compiled for ARM, looks good. And we can, now I am on a x86 hardware, but we can, using the readelf, should be -t readelf command, we can check the dependencies. OpenCV hello. So this is for ARM now, but we are able to check the dependencies with the readelf tool that you can see now. These are the needed parts. So the Qt widget, Qt6 widget is needed, Qt6 GUI is needed, core is needed, and OpenCV core and this image processing process, whatever, this are needed from the OpenCV. So it looks good. So we are able to create the OpenCV, cross-compiled OpenCV Qt together, and the link necessary dependencies for this binary. Looks good. So let's try on Raspberry Pi. You need to send OpenCV binaries and Qt OpenCV hello to the rasp. I don't remember the IP address. Let me check. I connected via VNC, but I don't remember the IP address. Cool. 178.41. 178.41. Like here, home rasp. Let me check again. Home rasp. So we send them. I did before. So if you check here now, we have OpenCV binaries and Qt OpenCV hello example. So this is also, you need also this one, right? So from the container, when you create the image, you should copy also this, but I didn't show you. So yeah, I did before, because you should watch the previous stories. That's why I said you should watch the previous stories. You should extract this one and this one together. So tar here, I did before, under USR local Qt6, that we can do it again, but it's not necessary. And also for the OpenCV, using the same command, xvp OpenCV binaries -c USR local and OpenCV that I just created before. Let's do it again. There are the files exist. I did before because it is asking me, I did before. There is already this file, and you need to export, the library path. For this one is for Qt6, and where is the other one? I don't see other one. Let's do it right now. So this one is for OpenCV. So I just extract the binaries here. That is it. Now it's ready to run the application. This is the moment of truth, right? So we didn't touch anything in the Raspberry Pi. We compiled OpenCV and Qt together, and now it gives an example also. Everything looks good. And now we are going to run the example. Perfect. It's like a magic. Of course, I updated the Raspberry Pi before, right? So I just run here. If you check the Dockerfile rasp, so I install everything here to the Raspberry Pi, but you don't need everything again. But I just update the Raspberry Pi. But this is amazing. So guys, that is it for me here. If you have any questions or if you see any problem, let me know, because I just tested with this simple example. There could be a dependency issues or something, that just then tell me. I will check it. It is okay. Don't forget to subscribe, and don't forget to give the start for the repository, and see you again. Bye bye.